Hi everyone. We're going to resolve a vector into its x and y components, and you're giving the vector. So this first vector we're given is 5 meters at 40 degrees north of west. And we want to find out what our y and x components are. So what I'm going to do is draw it again, and keep in mind on these drawings I do, they're not scaled to proportion. You just get the general idea of what we're going to do. So when I have it, I'm going to draw my 5 meters here, and this is 40 degrees, and I'm going to draw down. So this is my x component, all right, and this is my y component. So we're drawing tail to tip, and I didn't do a very good job. So let's do it again. So from here you're drawing up, tail to tip. All right. This is your x component. This is your y component, and this is already 5 meters. And what you're going to need is your calculator, because I'm going to go kind of quickly on this and just give you the answers. And make sure your calculator is in degree. The mode is in degrees, not radians. So the first thing we're going to do is, when we draw this down, we're going to use sine of 40 equals y over 5. So 5 sine of 40 equals my y component. And when you do that, and we're going to round to the nearest tenth, and when you get this is going to be 3.2 meters. So my y equals 3.2 meters. And my x, we're going to use cosine of 40 equals x over 5. And so that would just be 5 cosine of 40 equals your x. And when you do that in the calculator, you're going to get 3.8. However, since it points to the west, it's negative. So since we're going to the west, that's negative. So we have to put the negative sign in front. And that's basically all we're going to do on all of these videos. The next one we're going to do has a little issue, so let's talk about it. Okay, we have one like this. And this is 49, this is 11 meters at 49 degrees west of north. And if I do this, and I'm going to erase this, basically if I do this, and then try to do, let me do it from here, sine and cosine, let's look at this. If I do it this way, I'm going to get sine of theta, or in this case 49, is opposite. And when you go opposite here, you're going to get the x. And that can be confusing. So that'd be x over 11. And you're going to get the x with the sine, and we're used to getting the y with the sine, the vertical with the sine. So just to avoid confusion, what I like to do, instead of doing what we just did, I like to go ahead and just figure out, since this is 90 degrees, that this would be 41. And we're used to drawing it in trigonometry the tiny way. So I'm going to just write it this way, because all we need is the components, and get my x here, and then draw up and get the resultant. The resultant vector is 11 meters, but we need to get the x and y. Then you're not confused about your y and x and how you're drawing, especially if you don't have to draw it. All right, so we're going to get sine of 41 equals y over your radius, or hypotenuse, which is 11. So 11 sine of 41 equals 7.2 meters. And I'm just going to write it on the side here so the videos don't last too long. And then basically when you do cosine, all you're doing is changing this to cosine and this to x. And you're doing the same thing. So in the future videos, all I'm going to do is write this out. So we have 11 cosine of 41 equals 8.3 meters. However, since we're going to the direction is to the west, this is negative. Okay, and I'm not going to probably do this on the other videos. Okay, so that's your x and y components. So this is your y, 7.2 meters, and your x is negative 8.3 meters, since we're going to the west. All right, now we're going to go a little faster. We're going to just draw down for the resultant, and this would be your x, this would be your y, and all you're going to do is say, since our hypotenuse is 7, you're going to sine 7 times sine of 25 equals, and that's going to be your y, and 7 cosine of 25 degrees equals your x. And when you put that in the calculator, you're going to get y equals negative 6.3. You should get 6.3 meters. But since we're going to the south, that's negative. So we put the negative, and the same thing for the x. When you put that in the calculator, you're going to get 3 meters. But since it's pointing towards the south, or to the west, we're going to call that negative. Okay? Here we have one, and I'm going to draw the this vector up here. So this is your x component here, and this is your y, and you just use the 60 degrees and write what's our hypotenuse is 12 meters. So 12 sine of 60 equals, and that's going to give you, this one is, oh, this is really supposed to be 65. I already wrote these down, so let me do it right, because I don't want to have to sit here and use the calculator. Okay, so sine of 65, let's change it. I apologize. And you're going to get, for number 3, we got the y equals 10.9 meters, and 12 cosine of 65 equals 5.1 meters. We're in quadrant 1, and they're both positive. And this should have been, I should have wrote this north, south, east, and west. Okay? The next one, I have 25 here, and the 70 degrees is on this side. So what I'm going to do, so I don't have to get confused with my x and y, I'm going to go ahead and write this as 20 degrees here, because they're complementary complementary angles, so they should add up to 90 degrees. And then I'm just going to draw my x component and then my y component. So this would be your x and your y, and you just put this in the calculator. So we're going to get 25, that's your length here, sine of 20 degrees equals your y, and 25 cosine of 20 equals your x. Notice your x is going to be positive and your y is going to be negative. And what we get for this one is x is 23.5 meters, and your y is going to be negative 8.6 meters. Let me put it down here. Y equals negative 8.6 meters, and your x equals 23.5 meters. That's what you should get. Okay, I have 2 more quickly. Notice the 55 is here. These, so I'm going to go ahead and do the complementary angle thing. This would be 35, because that gives you the 90 degrees. And I'm going to draw my y component here. This is your x component. So you just do 14, that's your hypotenuse, 14 sine of 35 equals, and 14 cosine of 35 degrees equals. So when you multiply that out, your x is going to be negative 11.5 meters, and your y component is going to be negative 8.0 meters. So it's the same thing you do with north, south, east, and west. I did do a video earlier about how to call this, describe vectors. Again, this would be 14 meters at 35 degrees, or we're going to call this 55 degrees west of south. So if you don't know how to do that, please watch my previous video. And we're going to do one more. Again, this is a 37, so you're going to take a 90 minus 37, and we get 53 degrees is here. Draw the vector, your y component here. So this would be your x. And this is your 23 meters goes here. So we have 23 sine of 53 degrees and 23 cosine of 53 degrees. This is your y component. This is your x component. And what you're going to get is your x component is 13.8 meters. And your y component is 18.4 meters. Okay, the next vector we're going to be doing is describing vectors from x and y components. So they're going to give you the x and y, and we're going to have to find the magnitude and the direction. Have a nice day.